Hi guys, this is Mrs. Tucker. This is the video review for Algebra lesson 5-1 through 5-4 for our mid-unit test, for mid-chapter test. So let's get started. The first question is from lesson 5-1 on identifying linear functions. We're supposed to tell whether the given ordered pair satisfies a linear function. You can tell from ordered pairs if you've got a linear function or not by looking to see if you've got a constant change in your x's that corresponds to a constant change in your y's. If that happens, then it'll graph as linear. So let's take a look and see what our x's are doing. From 4 to 3, we subtracted 1. From 3 to 2, we subtracted 1. From 2 to 1, we subtracted 1. From 1 to 0, we subtracted 1. I have a constant change in my x. From 16 to 9, I subtracted 7. From 9 to 4, I subtracted 5. From 4 to 1, I subtracted 3. From 1 to 0, I subtracted 1. There definitely is a pattern there, but do I have a constant change in my y's? No. And because I don't, this is not a linear function. Now, what you guys could do if you wanted to is get your graphing calculator, press the button that says Stat, put in these ordered pairs under L1 and L2, then go press Stat Plot, turn Plot 1 on. I would connect the dots with a line. You're going to have to go to your window settings and make sure that your Y max is at least what? A 16, and then graph it. Okay? And then you can see what you've got. I'll bet it's not a straight line. Okay, and I see I got some kids that are plotting this out, so I'm going to pause a minute while they use their calculators and take a look at it. Okay, so my student here, Andrew, graphed it out. When he graphed it, it looked like that. It was not a straight line. Let's do number 2. Oops. Number 2 says, oh, look at these ordered pairs. I'm going to do this the lazy girl way, and if you're going to do it the lazy girl way, you better be careful. I'm going to highlight all my x values. And then I'm going to see what's happening with my x values. Increase by 1, increase by 1, increase by 1, increase by 1. I do have a constant change in my x's. They're all increasing by 1. I'm going to switch colors and I'm going to go highlight all my greens. And I'm going to do that so I don't make any mistakes, because you got to be careful if you're doing it the lazy girl way. From Y to Y, here I increased by 2. Here to here I increased by 4. Here to here I increased by 8. Here to here I increased by 16. Is this going to graph as a linear function? Why not?
Because the y doesn't have a constant rate of change.
Yeah, I don't have a constant rate of change in my y, so that is a big fat no. And if you graph it, once again, you're going to have yourself a nice little curve. Let's look at number 3. From here to here, what happened?
Minus 1.
From here to here?
Minus 1.
From here to here?
Minus 1.
From here to here?
Minus 1.
Okay. From here to here?
Minus 4.
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 Is that a linear function?
Yes.
Yes.
Because the rate of change is constant.
Yeah, because my rate of change is constant. Let me ask you a question before I move on. What if they had not included that point in this table? Would you have been okay? Because from here to here, what happened?
Minus 2.
Minus 2, what happened from here to here?
Minus 8.
Minus 8. But if you take the change in your y and divide by the change in your x,
You would still get the same answer.
yeah, you still get a constant rate of change. Negative 8 divided by negative 2 is positive 4. If you take negative 4 and divide by negative 1, you still get,
Positive 4.
yeah, you still get positive 4, which is your constant rate of change, also known as slope. So they could you know, they could take out a point. You just have to be mindful of that. All right, number 4, very, very important. Using intercepts. This one says a water balloon that holds 2 gallons of water is leaking and losing water at a rate of a half a gallon per minute. The function f of x equals 2 minus 1/2 x gives the amount of water in the balloon, not the pool, the amount of water in the balloon after x minutes. Graph the function and find its intercepts. What does each intercept represent? First of all, what are my 2 variables?
Minutes and gallons?
Yep, minutes, and it says f of x gives the amount of water in the balloon in gallons. You're right. So those are my 2 variables. And which one's my dependent variable?
The water in the balloon.
Yeah, the water in the balloon depends upon how many minutes it's leaking. I just wanted to make sure that you knew why I graphed these the way I did. Okay, I've got the equation y equals 2 minus 1/2 times x, and they want me to graph and find the intercepts. You can either create yourself an XY table, drop in some x's that are appropriate for this situation and solve for your y's, or you can change your equation to standard form and find your intercepts that way. Let's do that. How do I change this to standard form?
Oh, you plus the 1/2 x. Right?
Yeah, let's add 1/2 x to both sides. You're right. So I get 1/2 x plus y equals 2. And I've told my kids the only thing that standard form is really good for is to find what? Yeah, to find your intercepts. That's really the only thing that I think standard form is good for, is to find your intercepts. Okay, what's always true of your x-intercept?
That the y is 0.
The y is 0. What's always true of your y-intercept?
X is 0.
Okay, let's put in an x of 0, or I'm sorry, let's find our x-intercept by putting in a y of 0. That goes away. 1/2 of what number gives you 2?
4.
Yeah. So this has got to be 4. Let's find our y-intercept. Let's put in an x of 0 and cover that up. Our y-intercept is what? 2, yeah.
Because it takes 4 minutes to drain 2 gallons out of the balloon.
Well, you're ahead of me. Let me graph this first. Yeah, you're ahead of me. Oops. Okay, so my x-intercept is 4, 0. My y-intercept is 0, 2. I'm actually not going to do that. I'm going to connect the dots with a line. And let me do this. Do you like the way that I connected the dots with the line? Huh?
Yes.
Let me do it bigger. Let me do this. Do you like the way I connected the dots with a line?
No.
No, because if you do that on your test, I'm going to circle this and I'm going to circle that, and I'm going to say -1 and -1. Why?
Because
I can't have negative. What?
the water in the balloon.
Yeah, you can't have a negative amount of water in the balloon because when it's drained, it's done.
And then you can't have negative amount of time draining the negative amount of water out of the balloon.
That's right. You can't have negative time, you can't have negative water. So we're just going to do this to connect it. If I can get the right tool here, grab this, and we're going to connect it with that type of line. Okay, we've graphed it. Graph the function and find its intercepts. All right, I found the intercepts. I have an x-intercept of that and a y-intercept of that. They want to know, what does each intercept represent? Okay, you got to be careful here because I'll see this every year. I'll have somebody say, well, your y-intercept is minutes and your x-intercept is gallons of water in the balloon. And that is not correct. If you say your x-intercept is minutes and your y-intercept is gallons, what you did was you just told me the label for my x and my y-axis. You did not tell me what the intercepts represent in the context of this problem. What you need to do for the x-intercept, look at your x-intercept. I want you to tie in this number, this number, this label, and this label into your explanation. Does somebody want to try that? Sarah.
It takes 4 minutes to drain 2 gallons of water out of the balloon.
Did you hear what she said? She says it takes 4 minutes to drain the 2 gallons out of that balloon. Yeah, that's correct. Let's talk about our Y-intercept. In the Y-intercept, you need to pull this number together with this number and this unit together with this unit, or those two labels. What's the meaning of my Y-intercept? Anybody want to try that one? Yes, Mallory.
It's the volume that it starts with.
It's the volume it starts off with, yeah. Be more specific. Throw a number in there. Besides 0. At 0 minutes,
At 0 minutes, it's 2 gallons.
there's 2 gallons of water in the balloon. Yeah, before the balloon has started leaking, there's 2 gallons of water in the balloon. Good. Good, good, good. Here is number 5. Use the intercepts to graph the line described by each equation. If we're going to use intercepts to graph, our equation has to be in what form? Yes, I heard somebody say standard form. Is our equation in standard form? Yeah. What's always true? My x-intercept? Y is 0. If my y is 0 and I cover that up, what's my x-intercept?
Hold up.
4 times what gives you 12?
3.
3, yep, so that's 3. What's always true of my y-intercept? X is 0, cover that up, and I get -3 times some number is 12. What's my y? -4. Graph your 2 intercepts and connect them with a line. 3, 0, 0, -4. Make sure, because this is a negative problem, what kind of line do you want to have? You want to have a solid line with the arrows at the end. Yeah. Make sure you have your arrows on the end. Why do we need arrows on the end? Somebody, why do I include the arrows? Yes, ma'am.
So the line is continuous.
Why do I know the line's continuous?
Because the domain's all real numbers.
The domain's all real numbers. Yeah, it didn't give us a domain, so we assume it's all real numbers. Man, I've done a good job with these kids. Yeah. Okay, number 6. They want us to graph using our intercepts. First, is my equation in standard form? It's got to be in standard form before I can graph using my intercepts.
No.
Is that not in standard form? Oh, well, if you use commutative property of addition, you could say 8x plus -2y is 16. So it's pretty much in standard form. Yeah. Okay, let's use the cover-up method. Let's find our x-intercept, cover up our y, and our x-intercept is what?
2.
Not 2.
Oh, wait. Oh, wait, that'd be -2.
That's -2.
Yeah, I didn't see that.
That's okay. My y-intercept is where x equals 0. Cover that up. What's my y-intercept? 8. -2, 0, 0, 8. 1, 2, 3, 4, 5. I'm going to have to call each line worth 2. That's what I'm going to do. Each line is worth 2. 2, 4, 6, 8. If you guys do that on a test, you guys need to show me that that's how you gridded it out. Would you do that for me? By doing at least that so I can see what your scale is, so I don't get confused. Don't confuse the teacher. I'm easily confused because I'm getting old. Does your graph look like that? Okay. We're ready for 7. And I'm almost about to run out of time for this session. Let's put this thing in standard form first. What do I want to do? Yeah. We're going to add 4x to both sides. So I get 4x plus y equals -5. My y-intercept is where x equals 0.
-5.
So, yep, that's -5. My x-intercept is where y equals 0. What's my x-intercept? -1 1/4?